Traditional web pages and applications rely on synchronous communications. In response to user actions, the web browser makes requests to the server, which processes each request and returns a full web page that the browser renders. And the cycle repeats for as long as the user is enamored with a website. Information shown in a page can quickly become stale under this model. And if it's data that the user can update, it may cause conflicts with existing back-end data or state information within the application. Ajax provides a solution for some kind of applications, but it's primarily a one-way request. The user or browser has to trigger a request to the server in some way. Fundamentally, this uses the traditional request response of the web. So this approach really doesn't handle real-time requests. You can set things up for longer-term communications, but they tend to be bulky and cause a heavy touch on the server. There are several options that people have created over the years to solve this need, some of which make use of long-time browser features, so they're usable with virtually all browsers used today, even those by a minority of users, and others that take advantage of brand spanking new features, like WebSockets in HTML5, which only modern versions of browsers support. Let's take a look at 4 of the best available options today for implementing real-time communications. One of the options is HTTP polling. HTTP polling creates an ongoing conversation by simulating a constant connection to the server using a series of AJAX requests. 2 common ways of implementing this is to use a JavaScript timer to send regular recurring requests, or to create a new request immediately upon completion of the previous request. Each new request fires whether the previous request succeeded or failed, which provides a measure of fault tolerance. The response from each request can bundle together all of the server events, change data, new information, whatever, that occurred since the last response was generated. So there's a kind of decoupling of actual events from the response to the client, giving this option its pseudo-conversation kind of a nature. Polling is one of the more reliable and fail-safe types of real-time communications. It really isn't real-time, but comes pretty close for all practical matters. But the reliability comes at a potentially significant cost in network traffic, with constant requests from clients and the requisite processing of each request, no matter how small and efficient that might be, particularly if there's absolutely nothing new to send down to the client. As a result, the server spends a lot of time processing requests that return no data at all, which is not a great situation. Nevertheless, if this is the only option you have, it can work very well. Pretty much the only requirements for HTTP polling are JavaScript support and the availability of the XML HTTP request object that supports asynchronous AJAX requests. So, support for polling is pretty widespread across all platforms today. The big downside to this technique is the potentially huge number of requests from clients relative to the responses that contain meaningful data, unless server events are happening fast and furious. So polling is hugely wasteful. Another problem is that client and server events aren't in sync, so it's possible for many server events to occur between client requests. And you have to be careful not to create, and in fact to actively protect against, a denial of service attack against your own server. So it definitely requires some careful programming relative to the kind of events that you need to return information about down to the client. There's an interesting variation of HTTP polling that can alleviate some of the drawbacks of that technique. HTTP long polling keeps each AJAX waiting until something interesting happens, essentially by not generating a response immediately. So the client makes a request, and the server keeps the connection open until it has something meaningful to return to the client. Compare this to the regular polling technique, where the client makes a request, the server immediately responds, usually with no data, and the client immediately makes a new request. Okay, so the client in HTTP long polling is making each request with the expectation that there's going to be some future server event that will generate a response. So instead of immediately generating a response to each client request, The server blocks the incoming request until a server event occurs or the request times out, or something happens to the connection between the client and the server. No matter which of those things happen, the client then immediately initiates a new request, which again is blocked until something interesting happens on the server. Now, there are a lot of different ways to implement long polling, and support for various techniques differs widely across browsers. The problem with this technique is that standard HTTP requests and responses are not built to handle long-lived connections. Traditional web requests require a connection between the client and server only long enough for the server to immediately generate a response, which generally closes the connection. Now, sometimes it takes some time for a server to generate a response, often because of a long-running database query or network latency. And these tend to be pretty unreliable. HTTP just wasn't designed for leaving connections sitting open. Long connections also tend to get broken, so they're often disconnected. This is actually part of the long polling workflow. If a connection is broken without a response, the client simply makes a new request, which is the same response as for a successful request that returns data. But this all adds a level of complexity to the technique that doesn't help its reliability. Server-sent events is yet another variation on polling. It's similar to long polling in that the client makes a request and the server responds when and if it has meaningful data to send to the client. But rather than closing the connection with each response, the server keeps the connection open indefinitely. This allows the server to send additional responses as meaningful data becomes available. This technique enables one-way communication from the server to the client. This means that the client is not able to send any additional requests or data to the server after the initial request on the same connection. Instead, the client needs to make additional AJAX requests on a new connection. Fortunately, this doesn't usually require closing the existing connection to the server, but it means that you can have multiple connections open between the client and the server. This technique often uses the Event Source API, that's a part of HTML5, which you can use to manage server-sent events. This API is supported in modern versions of most of the widely used browsers, with the notable exception of Internet Explorer as of version 10. And as of right now, I have no idea whether Microsoft will see fit to include it in a future version. The main downside of server-sent events is that it only supports communications from the server to the client, so it's not bidirectional. But clients can still communicate with the server using additional AJAX requests, which can use any of the communication models, including the traditional HTTP request response. The fourth of the common real-time communications models is the only one that really is real-time and bidirectional, and that's WebSockets. This is a new protocol that is part of HTML5. It essentially converts standard HTTP request connections into full duplex TCP connections channels with a secure communication option. Going forward, this is going to be the real-time communication technology of choice. The exchange between client and server involves an upfront negotiation. In essence, the client asks if the server supports WebSockets and is it interested in communicating using that technique. If the answer is affirmative on both counts, the server responds, passing back a key based on the client's request. Then, client and server can pass information back and forth as needed, effectively and efficiently. Browser support for WebSockets is growing, but WebSockets aren't yet a feature of all modern browsers. Probably a bigger problem is that even if a user's browser supports WebSockets, things like antivirus software, firewalls, and HTTP proxies can interfere with their use. But I expect that over time, WebSockets is going to become more widely supported and less widely interfered with. But who knows how fast that's going to happen. So, there are a number of choices for performing practical real-time communications using HTTP. But each of the four communication models that I've just discussed, each of them have quirks. And they vary quite a bit by how widely they're supported in even the most current versions of modern browsers. The best solution is to implement all 4 in your application and include a mechanism for deciding on a user-by-user basis which will work the best and provide the needed functionality given the browser model, its version, server capabilities, and the environment that all this is going on in. Sounds like fun, right? Well, to tell you the truth, it does kind of sound like fun. It would be fun to implement all 4 of those in an application. But the problem, of course, is that it really wouldn't be terribly practical and certainly not very cost-effective. So thankfully, Microsoft recognized this need and included features for task-level parallel processing in version 4.0 of the .NET Framework. Best of all, they created the open-source project SignalR, which is an asynchronous signaling library for ASP.NET applications. And I've really got to say, other than some weird-looking code on both the client and server side, SignalR really makes adding real-time communications easy. SignalR is a thick abstraction over an HTTP connection, requiring surprisingly little code to implement. Of course, this being a Microsoft product, it has features to get as wild and complex and as low-level as you want, but the straightforward stuff is almost trivial to do. The library consists of a server API and client libraries for both .NET client applications and JavaScript, so SignalR includes the components you need on both the server and the client side to facilitate message delivery and reception in real time. SignalR provides 2 programming models that you can choose from: hubs and persistent connections. First one I want to talk about is a persistent connection. This uses the aptly named persistent connection object, and it supports lower-level socket communications or connections between the client and server to exchange messages. Each client connection to the server is identified by a connection ID. The server has the capability to either communicate with individual clients or broadcast to all the clients, or even to selectively communicate with a group of clients. You have a lot of flexibility. A persistent connection is the lower-level programming model of the two, which is closer to the reality of the underlying HTTP connection. In fact, it creates a development surface which is quite similar to programming with sockets, although here it's done on the virtual connection that's established by SignalR. This is how SignalR isolates the application from the transports and complexities that are inherent to keeping a permanent connection open between the client and the server. Persistent connections provide everything that you need to create real-time multi-user applications through a really simple and intuitive API. Nevertheless, the creators of SignalR have taken it one step further, providing another much higher level of abstraction above web protocols, transports, and persistent connections, and that's hubs. Hubs provide a higher level RPC framework than a persistent connection. If you have different types of messages that you want to send between server and client, then using hubs is recommended so that you don't have to do your own dispatching. Hubs use an imperative development model based on the flexibility of dynamic languages, such as JavaScript and C#. Hubs are the higher level API that we can use to access the persistent connection that's created by SignalR. You can create the same SignalR-based applications using persistent connections in hubs, but things are just simpler with hubs. Hubs let you make direct calls between client-side and server-side methods transparently. That is, from the client, we'll directly invoke methods available at the server and vice versa. As you'd expect, this is implemented through a client-side proxy that abstracts away most of the messy details of performing real-time communications with SignalR. Now, the methods of the proxy objects implement AJAX-style calls to the real methods on the server. Conversely, when the server invokes a method by the client, it's resolved by using dynamic types and a special protocol that kind of packages these calls at the server and then sends them to the other end using the underlying transport. For the most part, I recommend that you use hubs when you need to send different types of messages with various structures between the client and the server. Persistent connections operate mainly on text strings, which means that you have to parse data manually, which can sometimes be kind of laborious. But with hubs, most of the work is done by the SignalR framework itself, in exchange for a very small additional load. Now, the way SignalR works is that it uses WebSockets if they're available. SignalR supports 4 communication models, most of which I've already covered in this section: WebSockets, server-side events, and long polling, as well as a variation called Forever Frames that uses an embedded iframe to manage the client's side of the communication. SignalR uses WebSockets if they're available, and then automatically falls back to the other communication models as necessary to fit with what works with the client browser and the environment. This is the single best part of SignalR. You can let it make the right choice of which technology to use underneath in order to keep the persistent connection going. And that frees you from worrying about the compatibility issues and lets SignalR manage the communications between the client and the server. And that really is the essence of what is really cool about SignalR. The sample application is kind of a cliche when talking about real-time communications between server and client. What it is a chat type of application that I've named Chatter, obviously in the spirit of the folks who named Twitter. This is an MVC4 application that I adapted from numerous samples that are floating about the web. The first thing you have to do to create a SignalR application is to install it in the project. This is made almost trivial using a NuGet package that Microsoft keeps updated. As usual with NuGet packages, you can install the package coming up here to Tools and Library Package Manager, and you can go to the Package Manager console or use the GUI interface, the Manage NuGet Packages for solution. I'll take a look at that. And because it's an MVC application, there's a lot of stuff installed, but I'll search for SignalR within my installed packages. And you can see that I have the core components. I also have a JavaScript client. There's a couple other things in here, and that's really the main package there. So when you install the package, it sets up everything that you need in order to create these kinds of applications. You do need to do this step in order to run the application within an ASP.NET application. Okay, and there's a lot of dependencies between these different packages, and NuGet just does the right thing for you. Okay, so we have SignalR, a number of other things. I'm going to go ahead and run the application now so you can see what it does. Okay, first thing I'm going to do is copy that URL because I'll need that. And I'll enter myself as Don and go to a Chatter page. And I can do things like, hey, say hi Chatter. Okay. All right, now what I'm going to do is open up Firefox and go to the same address. And this time I'll be Carol. Okay. So I'm going to put these side by side. There we go. Okay, and Carol will say hi Chatter as well. And as you can see, now that Carol's online, it's broadcast to all clients. Again, because that's how I've configured this particular application. Once again, you can broadcast to individual clients, groups of clients, however you want to do that. And you can go back and forth and continuing to write banal messages back and forth. Okay, so that's how the application works. I'll go ahead and shut it down and let's take a look at the code. So I'm going to start at the front and work our way back. So I'll go over here into Views and look at Home and the Index View. The Index View just provides a place for the user to enter the username. There's really not much in the way of validation other than to verify that the user entered something. Okay, so let's start and look at the HTML down here. Okay, so you can see there's a div, enter your username, there's an input text, max length or size and max length, input, button, go chatter, and so forth, and then any messages that appear, okay, if there's any kinds of problems. So very simple there. And then we have some JavaScript code here. Obviously uses jQuery as a library to simplify the code. So all this is really doing is providing some UI features. So when the HTML is loaded and ready to go, I define a click event on Go Chatter. Again, that's that button right there that I clicked after I entered my username. And it's just going to run the chatter function. Okay, and then this next little bit of code here just hooks up a key press so that I can press the enter key instead of having to click on the button, and then putting the focus into the username text box. All right, then the chatter function is really the main code that's going on within this particular page. So it first goes out and grabs the username, checks to see that it's non-empty and not null. So if it is one of those, then it's going to print out a message that says, please enter your username to chatter with. It shows that, puts the focus on username again, and returns false. Okay, so some very simple kind of validation. You can obviously build on that whatever you want. All right, otherwise, if we pass that gauntlet of validation, then we hide the messages. We just navigate to the chatter view. Okay, strictly speaking, we're calling an action method and passing in as a query string parameter that username, whatever the user entered in. Okay, simple code, just UI, nothing really, anything about SignalR here. And one caution about this. The way I did things here, just to keep things simple, it does have some inherent protection against cross-site scripting attacks, but in a real application, you'll need to be a lot more robust in protecting against common attacks, particularly because you're working with data that the user input. Okay, next thing to take a look at is the home controller. And we have the basic index about contact. I really didn't change these much from the standard application. But then here's the chatter action method. So it gets that string username. So the model binding is going to pick that up from the query string parameter. It's going to save that in session state. It's going to put it into the view bag and then just return the view. Okay, kind of boring code here, just standard stuff with MVC to just essentially display a view but provide a little bit of information. Okay, now I want to look at the global.asax. So I'll come over here and I'll open up that file. There is one configuration thing that you need to do, and that's to define the routes that SignalR is going to use. So with the hubs programming model, this is almost trivial. So all you need to do is add this line of code right here as the first thing within application start. Now there's other places you can put this that have the same effect, but it's simplest by just putting it as the first line of code within application start. Okay, so if I hover over this, you can see that this is an extension method that builds the routes for you. So this is almost magic. It just picks up and it builds the routes that are necessary to support SignalR between the client and the server. Because again, it provides both a server-side API as well as a client-side library. Okay, now it's time to look at the server and client sides of SignalR. So I'm going to go over here and I created a hubs folder here and put in a chatter hub. Okay, so this is the server-side code that supports SignalR. Yes, this is really all that's needed on the server side for the chatter application. Now, you can get a lot more complex than this. SignalR is a very complex library, but this is all you need for a simple application like this that just needs to chat back and forth. All right, so what it does is this creates a class, Chatter Hub, that inherits from the hub object that, as you expect, is part of Microsoft.ASP.NET.SignalR, and then need to implement the send method. Okay, and if I go here and right-click on that and go to definition, that'll open up, and you can see that there's various methods here, or various kinds of support for different kind of connections and managing the connections. All right, so let's go back over to this Chatter Hub. Okay, so again, you can get way more complicated for more complex application needs, but this is it. Just call clients all. I'm going to send it to all instead of individual clients. Add new message to the page, and in this case, this is the name that the user entered, so that's a parameter, input parameter, and then whatever the message is. And again, you can define whatever parameters that you want to. Okay, then the last piece of the application is the chatter view. So I'll come back down here. And this is really the page or the place where most of the interesting stuff is for the application. So it's all on the client side here. Okay, so first thing, just take a look at there it is, the HTML right there. There's just a div class, the class container. There's an input type of text and message, a button. So this is where the user can type messages that are going to be broadcast to all the users that are currently connected to the server. And then I also used a hidden input field here for the display name. Just makes it a little bit more convenient in order to work with the user's name. And then an unordered list that called discussion, which is where all of those messages go. Okay, so here's the JavaScript code that supports all of this. Okay, so the first thing is we have this chat object right here, which is going to hold a reference to the proxy object. And this is going to use the name that we defined as the class right there. But as you can see, it's lowercase, so you have to name it because JavaScript is case sensitive. Yet it's uppercase C on the server, but for the proxy object, it's a lowercase c and then uppercase h. Okay, so this holds a reference to that proxy object that's created on the client that takes care of all the work of communicating with the server. All right, then the next thing it does is it defines this add new message to page function. So that corresponds to the method that was defined in ChatterHub on the server. So this is what the server is going to call to send a message to each client. So if you look back over here, that corresponds to that method right there, which was dynamically added to this object. Okay, so when the server calls this message, it does a little bit of user interface stuff. It gets the name and message, and then it appends a new line item to that discussion unordered list. And it puts in the date, converts it to the time, a little bit of formatting and so forth, and displays the name and the message. And I go ahead and HTML encode that in order to protect against certain types of attacks. Okay, then it also sets the display name to the value of the username within the view bag, and then sets the focus to the message. All right, and then this is a little bit of code here. Defines the click event function for the send message button. And this is the code that causes the page to send the username and message to the server to all of the clients. Okay, so it's attached to the send message. So, well, let me back up. So what this has done is this is sort of like the ready function, but this is the ready function for SignalR. So when it's all ready to go, it defines this event on the click event function for send message, and it just uses this send method in order to pass the display name, which is the user's name, as well as the message. And it's just again using jQuery in order to extract the value of those elements. And then once it sends the message, it clears out the contents of the message box and sets its focus so the user is ready to send another message. Okay? And then this code just hooks up a key press event here so that the user can press the enter key or click on the button. All right, another interesting thing about this is these scripts up here. All right, so the jQuery and Modernizer references are in the underscore layout page. Okay, so usual kind of stuff. But then in this view, because it uses SignalR, it needs to reference SignalR. Okay, so it has that reference to jQuery.signalr-1.1.2.js. And then I also use this date.js, a really wonderful open source library for working with dates and times and so forth. But what's this thing right here? That looks a little bit weird. Okay, what this is this is a virtual script that implements the client-side proxy object. And so this is the client-side object that makes the magic happen. So you can look at that within different developer tools within the client and see the custom script that was generated by SignalR on the server and sent down to the client to make the magic occur. Okay, so that's it for implementing a very simple SignalR application. Most of what I showed you is just UI stuff, user interface stuff. Keep in mind that I used a SignalR hub for this application. An application that uses a persistent connection instead of a hub would be a bit more complex, but to tell you the truth, really not all that much. But in either case, you have a lot of flexibility in how you implement SignalR.